Assalamu alaikum. Welcome to Telikilaas on chemistry. Previous class you have studied on alkanes, the isomerism of alkanes and the physical properties of alkanes. Now we are going to see today chemical properties of alkanes. Now alkanes do not undergo much reactions. Alkanes are fairly unreactive, that they do not undergo many reactions. But there are two reactions that alkanes undergo that is mentioned in our syllabus, that is substitution reactions of alkanes with halogens and also combustion reactions of alkanes. So first we are going to see substitution reactions of alkanes with halogens. Alkanes react with halogens, as you know, if you look at the periodic table, group 7 elements are known as halogens. Something that you need to remember here is that alkanes, just like that, do not react with halogens, provided that with the special conditions, that is in presence of UV light, only this reaction occurs. Now halogens reacts with alkanes in order of their reactivity. Now if you look at the group 7, the halogens, you will see that fluorine, chlorine, bromine, iodine, acetylene. Then when you go down the group, the reactivity decreases, meaning that fluorine is the most reactive halogen. So obviously when alkanes reacts with fluorine, that will be faster than chlorine, then bromine, and then iodine. So the reactivity will go like this, the reactivity decreases down the group. Now first we will see, when we say substitution, what does that mean? Substitution means replacing the hydrogen atom in the alkane by another element. Now this time it is a halogen. So we will take an example here. This is the general equation. When an alkane reacts with halogen, it forms haloalkane and hydrogen halide. Haloalkane here is the organic product and hydrogen halide will be the inorganic product. So we move to the example, that is reaction of methane with chlorine. Methane is the first alkane, the most basic alkane, with chlorine. So this is what happens here. You already know how to draw methane molecule, CH4 like this, and chlorine, we know that all halogens exist, they exist as diatomic molecule, meaning that two atoms of chlorine bonded together. Now here what happens is, how we get this product is, now methane, there is 4 hydrogen atoms. One of the hydrogen will be replaced or substituted here. The hydrogen atom will be replaced by the chlorine atom, and this hydrogen will be combining with this chlorine to form hydrogen chloride. So you can see the product here. See, this hydrogen has been replaced by the chlorine atoms, and you have 3 hydrogen atoms with the chlorine. So this is the reaction. Now we can write the reaction using molecular formula also, right? CH4 reacting with chlorine, CH3Cl. You can see that one of the, here is 4 hydrogen atom, 1 hydrogen has been replaced, leaving 3 hydrogen here, and chlorine has come here, then hydrogen chloride. Now the name of this molecule is chloromethane, and also it is also known as monochloromethane. Why mono? Because 1 chlorine is there. And this is the organic product, because sometimes you are asked to draw or to write the molecular formula of the organic product that has been formed. So you have to know how to identify the organic product and the inorganic product here. Now this is not the end of this reaction, because the hydrogen, this reaction will go on until all the hydrogen atoms gets replaced by the chlorine atoms. Okay, so this monochloromethane further can react with the chlorine to form dichloromethane. So what is happening here? Again the same thing gets repeated. Now this time let's say this hydrogen atoms gets replaced by this chlorine. So chlorine comes and take over this hydrogen atom, and the hydrogen atoms will join this chlorine to form hydrogen chloride. So you see the same process keeps on repeating. So here now it is chloromethane, that is the product that we got in the first reaction is further reacting with chlorine to form dichloromethane. Again, why it is di? Because now that there is two chlorine atoms, so it is dichloromethane forming hydrogen, and also hydrogen chloride is formed. Now do you think there will be more reactions? Yes. Why? Because still there is two hydrogen atoms that can be replaced by the chlorine atoms. Alright, so similarly here also the dichloromethane is reacting with chlorine again to form trichloromethane and hydrogen chloride. Still one more reaction, right? Because there is one hydrogen that can still be replaced. Now you can see the product has no hydrogen atoms, all the hydrogen atoms has been replaced, meaning that we have got tetrachloromethane because there is 4 chlorine atoms, tetrachloromethane and hydrogen chloride. Now all this occurs in a mixture, so it is not pure, we cannot get pure. How do we identify whether a substance is pure or not? If it has a fixed melting or boiling point, right? So here all this occurs in a mixture, you will find all these products in the mixture, so there will be no exact melting or boiling point here, right? So that is what is substitution of reactions of alkanes with halogens. Now comes to your task. Can you try this? Write equation for the reaction of ethane with fluorine. Now what do you think? Will this reaction be faster than the reaction of methane with chlorine? What do you think? Yes, you are right. This reaction will be faster. Why? Because it is reacting with fluorine, and fluorine is more reactive than chlorine. Okay, now you can try this. Ethane, how many of you remember the formula? C2H6, fluorine, F2. Now one of the hydrogen will be replaced by the fluorine atom, so C2H5F plus hydrogen fluoride, that is HF. Now this product can further react with fluorine to form C2H4F2 plus HF. So what is happening every time? One hydrogen is reduced by 1 and fluorine gets added by 1, right? So there will be more reactions in this case. Why? Because there are more hydrogen atoms. Now in ethane there is 6 hydrogen atoms, meaning that this reaction will go on till all the 6 hydrogen gets replaced, as you can see here. So you can check your answers, see whether you have got this correct. If you have got this correct, meaning that you have understood how the substitution reaction of alkanes with halogens occurs. You may not be asked to write all the reactions in the paper, but usually they will ask to write one of the organic product. Usually it will be, you will be asked to write the organic product that is formed due to the reaction between alkanes with halogens. So any one of that, if you draw or write, it will be correct depending on the question. Right, so we are done with the substitution reaction and we move the next reaction of alkanes, that is reaction with air or oxygen, in other words combustion reactions of alkanes. Now, gaseous alkanes such as methane burns in good supply of oxygen, meaning that when there is plenty of oxygen available, then the alkanes react with oxygen to form carbon dioxide and steam. It is really important for you to remember the products that is formed here. Carbon dioxide and steam. And also note that when it produces carbon dioxide and steam, then that means this reaction is called complete combustion. So, remember that alkanes, when it undergoes, when it burns in plenty of oxygen, then it undergoes complete combustion and the products are carbon dioxide and water vapor or steam. Look at this reaction. Methane, CH4, reacting with oxygen to form carbon dioxide and water vapor. So, if you are asked to write the products that or the reaction that has produced when methane is burned in plenty of oxygen or complete combustion, this is the way that you write the equation. Now, look at this. Do you know which alkane is this? C4H10. Yes, it is butane, right? Butane reacting with oxygen to form carbon dioxide and water vapor, meaning that butane has undergone complete combustion. Now, whenever you write chemical reaction equation, make sure that it is balanced. So, let us see how to balance this reaction. Okay. Now, balancing equation, always first balance carbon. Now, on this side of the equation, that means left side of the equation, there is 4 carbon atoms, right? 4 carbon atoms, but how many carbon here on this side? 1, right? So, first balance carbon atoms, put 4 in front of carbon dioxide to balance carbon. Now, count the number of hydrogen atoms on the left side, there is 10 hydrogen atoms. So, how to balance hydrogen here? There is already 2, meaning that you can put 5 here, because 5 times 2 will give you 10. Now, hydrogen has balance. Now, count the oxygen on both sides. On this side I have 2 oxygen, and here 4 times 2 it is 8. 8 plus 5 will give you 13, right? 13. Now, 13 is an odd number. How can we get an odd number by multiplying 2? No, right? Cannot do it. So, what can we do? There is a very easy way. If you get an odd number over 2 will balance the equation. As simple as that. 13 divided by 2. So, count the number of oxygen you get on this side. If it is an odd number like 1, 3, 5, 7, 9 like that, 13 is an odd number. So, 13 over 2 will, when you put in front of oxygen molecule, it will balance the equation. Or if you don't want to be balanced, if you don't want the equation to be balanced by a fraction, simply you can multiply the whole equation by 2 and you can get rid of the fraction. So, this will give you 2 C4H10. Now, this 2 and 2 will get cancelled out, and what will be left? 13, a whole number, right? 13 moles of oxygen, and this 4 times 2 will be 8, 8 carbon dioxide plus 2 times 5, it will be 10 water molecules or steam, right? So, this is the equation. So, both the way it is correct. Instead of fractions, you can even use decimals also. Okay. I hope you have understood this. So, this is a, maybe it is a new way of balancing equation. We used to always balance with using whole numbers, but now that we have introduced here fractions. So, remember that when you get an odd number and you are left only with an even number to balance, the odd number over 2, write it as a fraction and then you can balance it. Okay, so that is complete combustion. Now, you should know that alkanes it can react with oxygen, but if there is, let us say there is not enough oxygen present, which we say limited supply of oxygen, then alkane is burning, but it is incomplete. So, we call it incomplete combustion. So, in this case, what are the products? Now, this time it is not carbon dioxide, but it is carbon monoxide. Carbon monoxide and steam are the products here. So, look at this. This is again methane reacting with oxygen, but you can see it is carbon monoxide. This tells you that it is undergoing incomplete combustion, carbon monoxide and water vapor. Now, let us see if it is balanced. 1 carbon, 4 hydrogen, and here it is. Can put 2 here to balance the hydrogen. There is 2 oxygen, and here is 1, and there is 2, gives you how many oxygen? 3. Now, what kind of number is this? Odd number, right? So, odd number over 2 as a fraction, write it to get to balance the equation. Now, look at the next equation here. This is C4H10 butane reacting with oxygen to form carbon monoxide and water vapor, that is incomplete combustion. There is 4 carbon, so balance the carbon by putting 4 here, and then there is 10 hydrogen. So, to balance put 5 here, and then count the number of oxygen. This side we have 2 here, and here it is 4, and here 5 will give you 9, odd number. So, 9 over 2 will balance the equation. Now, there is one thing that you need to remember, that carbon monoxide is a poisonous gas which can react with hemoglobin, and then it will reduce the oxygen transport to the vital organs. So, it can be really a deadly gas if the concentration is too high. Okay. Then there is another possibility that alkane may react with very limited supply of oxygen, very less amount of oxygen. Then in that case it produces carbon and steam. This is also a type of incomplete combustion. In a very limited supply of oxygen, alkane produces unburnt carbon, that is also known as soot, and steam. This is incomplete combustion again. So, there are 2 incomplete combustion where one produces carbon monoxide, one can produce carbon. Okay. So, again similarly, by now I hope that you have understood how to balance the equation. So, remember to read the questions properly so that you will be able to write down the equation correctly. Okay. So, methane reacting with oxygen to form carbon and steam. This is butane reacting with oxygen to form carbon and steam. You can see how the equation is balanced. Now, this is what we call soot, that is when the fuel is not burned completely. All right, now we move to the last part of the alkanes, that is uses of alkanes. Alkanes are mainly used as fuels. Methane or natural gas is used for cooking as well as heating purpose. Propane and butane burn with very hot flames and are sold as liquefied petroleum gas. So, usually all the alkanes are used as fuels. Now, what are fuels? Fuels are substances which can easily burn, producing lot of heat. So, alkanes are mainly used as different types of fuels. Okay. So, today what did we learn? We learned the chemical properties of alkane. You should remember that alkanes undergo 2 types of chemical reactions, that is substitution of alkanes with halogens, that is group 7 elements forming haloalkanes and hydrogen halide. Now, haloalkanes are what we are talking about, the organic product. Now, it is not just one reaction, it can go on producing more products depending on the number of hydrogen atoms. So, every time a hydrogen atom will be replaced by the halogen. So, that is, and also one important thing is that substitution reactions occurs only in presence of UV light. That means it does not occur in darkness. And then we talk about the second type of reaction, that is combustion of alkanes. The product that is produced depends on the availability of oxygen. In plenty of oxygen, it will produce carbon dioxide and water vapor. If it is limited supply of oxygen, it may be carbon monoxide or carbon along with water will be produced. Carbon monoxide is a poisonous gas, and also unburnt carbon or soot will pollute the air. So, there is a harmful effect when carbon is or soot is produced also. And then we also learn how to balance the equations when combustion of alkanes has occurred. We introduced how to balance the equation by using fractions. You can practice those reactions, then it will become easy. And then now we have also talked about the uses of alkanes. Mainly it is used as a fuel because it produces a lot of energy. So, that is all for today. I hope you have understood what we try to teach you today, and hope you have enjoyed the lesson. All the students, please keep practicing and stay at home, be safe. Assalamu alaikum.